All right, guys, welcome to your review test one study guide. We're always going to do a review test after our regular test just to kind of keep some of the important old ideas fresh. These questions are all coming from Unit 1 stuff. You still have your notes from there, so you're welcome to use that as an alternative resource to this video. What I'm going to be doing in the video, though, is I'm going to be going over the even problems with you guys, and then I've included some odds in case you want some extra practice. And the answers to the odds will also be included. So let's go ahead and begin here on number 2. The first thing I want us to do is I want us to be able to solve an equation. All right. Now we didn't actually do this in Unit 1, but we kind of do it all the time. But I just want to make sure that we're good at it. So I'm going to throw a few of these in here. Now, when you solve an equation like this, I like to follow some steps, 4 steps, which I abbreviate with the letters DCMS. Good way to remember it is you could think of it as don't call me stupid. Easy to remember. But what the letters really stand for mathematically is the steps we're going to go through to solve it. Distribute, combine, move, and solve. So let me explain these steps as we go. So distribute, you guys know what that means. Anywhere you've got parentheses with a number on the outside, you're going to be distributing that number on the outside. So for instance, I can distribute this -5 in here, and I can get -5 plus 40m plus 2 equals -36 plus 7m. The next thing I'm going to do is combine like terms. Now, when you combine like terms, that happens on one side at a time. Okay, what do I mean by that? Look at the left side and the right side separately. On the left side, are there any numbers that are the same kind of term that you can combine? So for instance, -5 and 2, those are both just numbers, so we can combine those together. So let's do that. 40m is going to stay the same. -5 plus 2 is -3. Okay. Over here, there are no like terms to combine, so I'm going to leave that one alone. It's going to stay exactly the same. Now, some of you guys might be thinking, well, Mr. Bailey, aren't 40m and 7m, aren't those like terms? Yeah, they are like terms, but they're on opposite sides of the equal sign. And when I say combine like terms, I mean combine the like terms that are on the same side. So that's this step here. Now, actually, that concern's been raised. That's the next step. But I call that move, and I call it move because it means move the small variable, the smaller variable. So we have 2 variables up there. I've got 7m and I've got 40m. Now, if you've got, which of these is smaller? It's the 7m, right? So I'm going to move it to the other side, but the way you move it is by doing the opposite. So this is plus 7, so I'm actually going to minus the 7m on both sides. Okay, so that's going to be 40 minus 7, which is 33m. After that, you should have a 2-step equation, which I think I can just say solve, and hopefully you guys know what to do from there. On a 2-step equation, you do addition or subtraction first. So we'll do that. I've got 33m is equal to -33. And then we're just going to divide. And I end up with m equals -1. Okay, so those are the steps I'm recommending you guys to use there. Distribute, combine, move the smaller x, and solve. I like to move, you technically can move the bigger variable, by the way, when you do this step. It's just that it's easier to move the smaller one because you're more likely to avoid negatives that way. But anyway, so that's solving equations. Let's go ahead and take a look at number 4, the next even problem. So when it comes to graphing linear functions, we remember that we always want to start by graphing the y-intercept first. And in this case, that's -5. So I'm going to go down 5, and I'm going to put a dot there. So that's my y-intercept. The next thing we're going to do is we're going to use our slope. And when your slope is negative, like this one, that means you're going to go down and right. Now, if you have a positive slope, you would go up and right. But since we have a negative slope here, we're going down and right. And we start at the y-intercept that we had. So I'm going to go down 3 and right 5. So down 3 and right 5 would put me right there if I started at that y-intercept. And then we go ahead and just connect our dots. And there's my graph. Now I want you guys to remember a couple things. If you're ever missing a y-intercept, that means it's 0. So if you don't have a number right here, it's 0. But if you're ever missing a slope, like here, whether it's a rise or a run, then it's 1. Okay, so make sure you're aware of that if you ever have some missing numbers there. Let's go ahead and move on to number 6. So the issue with this guy is that it's not in the y equals mx plus b form, in a different format. And so when we have that, we want to get that y there by itself. And once we've done that, it'll be in slope-intercept form. And usually you want to start off by doing any kind of addition or subtraction. So I just minused the 3x on both sides. And then if there's a coefficient in front of the y, you're going to go ahead and divide it out. Reduce when you can. And now it's in slope-intercept form, and I'm ready to graph it. So we start at that y-intercept. We're going to go down 3, right 2. I'm going down again because I have yet again another negative fraction. So starting from my y-intercept, I'm going to go down 3 and then right 2 and put another dot. So down 3, right 2, and there's my graph. Let's go ahead and take a look at number 8. Looks like we got another one of those. Just a second. I think I want that to be different. There we go. That's the number 8 I want. Okay. So if you're ever missing variables, that's a different situation. So anytime you have y equals a number, those are going to be horizontal lines. And anytime you have x equals a number, those are going to be vertical lines. So in this case, I've got x equals a number, so I'm going to have a vertical line. And it's going to be at -5 on the x-axis, because it says x equals, right? And there's my vertical line. That's what that graph would look like. Okay. Now, if you have a y equals, it'll be a horizontal line. You'll count on the y-axis instead. All right, let's go ahead and take a look at number 10. Systems of equations. So a system of equations is when you have two equations with two variables and you want to find out what x and y both equal. That will work at the same time for both equations. So there are 3 ways that we talked about solving them. One is graphing, one is substitution, and the other is elimination. We're going to go over elimination and substitution in this study guide and test. The graphing part, we won't be going over that right now. So let's do the elimination steps first. So when it comes to the elimination, what I provided you guys with in the notes was a couple of steps that you want to follow. So the first thing you want to do is pick a variable to cancel. So I'm going to go ahead and say I'm going to pick the, I want to cancel out the y values. I could have done x, but I'm going to go ahead and do y. All right, so there's our first step. Next thing we're going to do is we're going to flip and distribute the coefficients of those variables. So here's what I mean by that. Okay. So the coefficients of the y variables are -8 and -6. I'm going to flip them. And what do I mean by flip? The -6 is on the bottom equation, so I'm going to put it on the top equation. and the -8 is on the top equation, so I'm going to put on the bottom equation, and so that's what I mean by flip, and then I'm going to distribute those numbers into each equation. All right, let's see what we get as a result. So for the top equation, if I multiply everything by -6, I'm going to get the following. Big number, 120 plus 144. On the bottom equation, if I distribute the -8, I'm going to get the following. All right. And that's the end of step 2. So the next thing that we do for elimination method is we're going to multiply one of the equations by a -1. Okay. So I'm going to pick one of the equations. It doesn't really matter which one you pick, but I'm going to go ahead and pick the top one here, and I'm going to multiply the whole thing by a -1. So I'm distributing again. And that's going to result in me having the following. The top is now going to be positive 6x minus 48y equals -144. And the bottom one is still going to be the same because I haven't done anything to that one. And those first few steps, those first 3 steps, what they end up doing for us every time is they end up giving us the y values, the one that I wanted to cancel out, right? By flipping and distributing the coefficients, I got the numbers to be the same. And then by multiplying by a negative, I got them to have opposite signs. So that way, I'm ready for the next step, which is add down. Or it could be subtract down, technically. So, oops, lost my number. So it could be subtracting down. But here's what I mean by that. Just combine these together. 80 and 6 makes 86. And these cancel. That's the goal. And actually, in this case, something interesting happens. These cancel too, but you can't just leave a blank over here, so that means 0. Here, you could put 0 here, but there's no point in putting a 0 on this side because 86 plus 0 is still 86, so why put it there, right? And then finally, after that, you're going to solve for the other variable. So at this point, we solve. Now, to solve this, all you would have to do is divide by 86. And I get x equals 0, because 0 divided by anything is 0. When you're all done doing that, step 6 is to plug in your answer to one of the original equations and solve. So I'm going to take that value for x, and what I'm going to do is I'm going to plug it into one of these equations up here. So I need a little more writing space. Erase some mess here. I'm going to take my answer for x, which is 0, and I'm going to plug it into one of these equations. And it shouldn't matter which one you pick, because they should have the same answer. And I'm going to plug that x equals 0. I'm going to plug 0 in for x then. So 0 minus 8y, that's just -8y. And then we just need to divide both sides by -8 to solve for y. And so I end up with 3. And so my x value is 0, my y value is 3. That is the coordinate pair, or the values of x and y, that will work for both of these equations. And that's the elimination method. Okay. Typically, you want to use the elimination to solve a system of equations anytime the x's and the y's and the constants line up like that. That's a good time for elimination to be used. But let's look at the other method for solving a system of equations, the substitution method, number 12. Substitution method, the good time to use that one is anytime you have either a y equals or an x equals. If you have one of those, that's a good situation to use the substitution method. So the first step is to identify the y equals, or x equals. Next thing you want to do is you want to circle what it equals. Now, you don't actually have to do this step. I just do this for teaching purposes, but I find it helpful if you're a visual person. So here's my y equals. Here's what it equals. And that takes us on to step 3. We're going to plug what I circled in to the other equation. So here's what I mean by that. Since y equals this, then I can replace this y in the other equation with that, since they're equal things. And so you have 4x minus 3, and instead of y, I'm going to put negative 5x minus 20 in there. After you do that step, you go ahead and solve. And this is where we get to use the don't call me stupid steps again, right? We distribute. Negative 3 times negative 5 is positive 15. And then negative 3 times 20, negative 20 I should say, positive 60. Then after we distribute, we combine like terms. And in this case, I don't have to move an x from one side to the other because I only have one x, so I can skip that. But we do get to solve now, so I'm just going to go ahead and subtract and then divide. All right. Now that's a weird number, but I'm pretty sure it's going to go in there nicely. The answer is going to be negative 3. And just so you guys know, even though it's technically possible to get fractions when you solve systems of equations, you won't get fractions in my class because the software I use doesn't do that. And I think that's fine. It's a nice way to know if you've done something right or wrong. So even though it is possible, if you get a fraction in this class, that means you probably want to go back and do something again because something went wrong. So after you solve, you're going to plug your answer in to solve. Well, plug it into one of the originals. And solve for the other variable. So now, once again, it doesn't really matter technically which equation you pick, but there is a good choice. I think this is the best choice because that's the one that has y by itself already, and that just makes it a little bit easier. So we know that x equals negative 3 now, so I'm going to go ahead and put negative 3 in there. Negative 5 times negative 3 is positive 15. And then with subtraction, we end up with negative 5. And so the solution to this system of equations is x equals negative 3 and y equals negative 5. Okay. Let's do another one here. Now, I included this one because something interesting will happen here. It's once again, it's another substitution problem because I've got a y equals there. So there's my y equals or x equals, and I'm going to circle what it equals, and then we're going to drop it down into the other equation, and let's see what we get there. Distribute. Combine like terms. Now, when you end up in a situation where the x's just go away, then you're going to be left with a statement, but not a solution, okay? So in this case, I have this statement, 4 equals 4. Is that true or false? Well, that's a true statement, right? 4 equals 4. If it's true, which it is, then the conclusion is that there are infinitely many solutions. In other words, there's more than one answer. In fact, there's an infinite number of answers to this system of equations. There's a whole set of points that where if you plug the same numbers in for x and y, it'll work for both equations. Now, in another event, let's say you're solving an equation like this and you end up with something like this. If you end up with something like 4 equals 0, well, that's a false statement. So if you end up with a false statement, that actually means there are no solutions to your system of equations. Okay, so keep that in mind. Now, this doesn't apply on this problem. This does. So the answer to this one is infinite solutions. But there is another problem on your paper today that does this. So if you're doing the odd problems, you'll come across that one. All right, let's go ahead and take a look at our last one on the study guide that I'll be going over. And that's to write the equation of this line. Now, to write the equation of a line, you need to find your slope. You need to find your b, and then you can write your equation and be all done. Okay. Now, to find your slope, you're going to need to use this old guy, y2 minus y1 over x2 minus x1. And these points up here are your x and y values. So if we just plug them in, y2 minus y1 over x2 minus x1, we end up with negative 3 over 2. So there's my slope, negative 3 over 2. All right, the next thing we want to do is we want to find our b value. The way that you do that is you take the formula, y equals mx plus b, and you plug in a couple of things. You're going to plug in a point, and you're going to plug in your slope. Okay, so I'm going to plug 2 in for y, 0 in for x, and negative 3 over 2 in for my letter m for slope. So if I replace the y with 2, the slope with negative 3 over 2, and the x with 0, I have that, and all I need to do is solve for b now. Now I got a little bit lucky here because my fraction times 0 is just going to be 0, and I'm left with 2 equals b. But sometimes you might end up with a little bit more here. Like, and we've talked about how when you do this, you think of this as a fraction, multiply top times top, bottom times bottom, and then to cancel out the fraction, you multiply everything by the denominator. That's something that we've talked about in other problems. Now I got lucky, like I said, on mine, and mine's 0, so it just goes away anyway. That kind of makes it easy. Anyway, once you have your slope and once you have your b value, then you are ready to go ahead and write your equation where you plug in your slope that you got from part 1, and then you plug in your y-intercept that you got from part 2 there, and that's the equation of the line that will go through those 2 points. So that's the end of it, and happy studying, and we'll see you guys in class. Bye-bye.